I had a lot of video ideas for today. I thought about working on our grill project. I thought about working on some more tongs and trying to build up to the forge welding of tong jaws to tong reins. I thought about doing some tools for the fire. I thought about talking about anvils. But what I really need to do is get some orders out. I've got a lot of customer orders piled up, and unfortunately doing YouTube videos takes away from that, so sometimes the YouTube video has to be about what I need to get done in the shop, but I think that's still going to be interesting. Right now I have an order for 34 of these little cabinet handles. And this is something I've made before. I keep a set of steps that I go through, so I know what my starting material is, what I need to prep it like, and what it looks like after it's bent. And I end up with a predictable little handle here. But since I've got 34 of these to do, I usually do 2 or 3 or 4, something like that. I just do them all by hand. But for 34, I thought it would be more efficient if I made a swage, because this is kind of a domed shape here, and I would like to have a swage that does that so they all end up the same, and it'll be just a little bit faster to do than trying to do that by hand and then filing it. So what we're going to do today is we're going to make a swage. A swage, of course, is a concave depression. It can be shaped like a spoon or a bowl or a half round or 90 degrees or whatever that depression that you need to work into. This one will be oval in shape and it will be tapered, and so it needs to be about 4 or 5 inches long. So whatever this measurement here is, and of course my ruler that usually hangs on the wall isn't where it belongs, so this is 4 1/4 is what that measurement is. So it's a little bit longer than most swages. A lot of times you would just start by reducing the shank so it fits in your hardy, and then upsetting a big block and turning that into the swage, but that usually limits you to about a 2, 2.5, maybe 3 inch swage. To do that for a 4.5 inch long swage is a fair amount of work. So I'm going to do something that I have never done before, and that is we are going to forge weld a square shank for the hardy hole onto a piece of steel. I'm going to cut this off and reshape this, but we're going to do a jump weld or a butt weld. I'll have to look and do some research, see if I can see what exactly this style of weld is called. But I've never tried this before. It's the way old tools were frequently made because it's so much faster and easier if you know how to do it than drawing it all out, especially if you don't have a power hammer. Now the power hammer, it wouldn't be bad to draw out. The way I might typically do this, admittedly, is make the swage and then weld it to a hardy shank and just use an arc welder. And that's pretty fast and easy. It's a good tool. There's nothing wrong with doing it that way, but it doesn't make for an interesting video. So we're going to try and forge weld this. Going to add to the difficulty. This is a hunk of truck leaf spring. It's about 5/8 of an inch thick. I'm going to do a little forging on it and reshape the part I'm going to use so that I can get my 4 1/4, 4.5 inch wide. This is 3 now, so I'm going to cut it extra long, draw that out, try and do an upset in the middle to prepare for the forge weld. My anvil has an 1 1/4 hardy hole, but I'm going to start with a 1 inch bar. At welding heat, I'm going to have to drive this down onto here, and I think I will easily upset it to 1 1/4 in that process. If I don't, it's not the end of the world if something like this fits a little bit loose in the hardy hole. It doesn't have to be real tight. So if it rattles around, that's fine, but I think I'll get that much upset. And we'll find out as we do this. So this is not a how-to video. It's not a tutorial. This isn't something I expect you to go home and do in your shop. It's just something so you can see how the process goes sometimes and how the learning process goes. After 30 years, I've never tried this, so what the heck? Sometimes you just got to go out on a limb and do something you've never done before. So follow along with me. Let's see what we end up with. So I've got a big piece of that leaf spring, should be something comparable to 5160. We're going to heat that up, and I'm going to draw it out edgewise and make it longer till it's about 4 inches long, and then I'm just going to clean it up till it's the shape I want for the top plate of the swage to be. Like I said, I don't intend for this to be a how-to project or a beginner's project by any means. It's something, a tool I need. I really wished I had had it this morning. I'm going to try and get it done so that first thing tomorrow morning I can start using this tool. So I'm going to use anything at my disposal in my shop to make it, other than the arc welder, unless this weld fails, and then that's what I'll do because I really need the tool. So just a brief minute under the hydraulic press. I don't know how wide this was to start with. 1.25 inches, 1.5 is what I want when I'm done, and it's still a little bit wider than that. That's now 3.5 inches. I think I'll go one more short round under there and try and get it out to about 4 inches. But other than that, it's getting close. By doing that under the hydraulic press, there's so much force, it doesn't upset the edges, it upsets the middle. It gets all that power right down to the middle, and I want that fatter middle when I do the forge weld. I need that extra material there. What I want to do here is I want to draw the ends out a little bit and leave it fat in the middle in preparation for that forge weld. It's a tough thing to hold on to. That's what I want right there. So in a fairly quick 3 heats, I've created a bar that's the size that I want my top swage to be. This will ultimately sit right over the hardy hole, right at the top of the anvil like this. And the impression will be lengthwise this way. It's ended up at 1.5 inches. I'm at 3/4 thick on the ends, but I'm almost a full inch thick in the middle still. And it's nicely domed, so that means when I bring my other piece in here, it will hit the middle first and start making that weld in the center of the weld and squirt all the flux and crud out around the edges as it welds, I hope. So the next thing to do is to work on our hardy stem. Like I say, this is going to upset some when we do that weld, but I'm going to start by upsetting one end of it to get it ready for the weld and kind of mushroom it over a little bit so I've got an edge that I'll be able to come back and hopefully weld down nicely. Looks like I forgot to turn the microphone on in the shop there, so we'll just describe this a little bit. Really, I'm just upsetting the end. I'm using a fairly heavy hammer that's about a 3.5 pound hammer. I just want to get a good swell on the end, so I've got something to work into the main bar of the swage. It is getting a little bit off center, so I'm going to need to center that up a little bit and get it straight again. And for that, I'm going to switch to a little bit lighter hammer. I don't need that great big rounding hammer for this. And that's most of what we need to do. Right now I'm just trying to get that all kind of symmetrical. And like I say, I want a dome in this section. So when I bring these two together, which is about to come up, that's all the right size now, I'll be able to drive that down on there. Now, this is going to take a little bit of practice before I do that. It's going to work in our hardy hole just fine. Anytime you're bringing two pieces out of the fire and forge welding them, you have to coordinate yourself and make sure they're going to come out of the fire just right. Luckily this piece, I don't think it matters which side's up. Sometimes it matters and you might have to find a way to mark that, but I think it'll be okay. But I'm going to have to come out, I'm going to have to keep hold of this piece, which is a little bit hard to get in the tongs just the way I want it. But I have to come out of the fire with both pieces at welding temperature, set that on the anvil, set that in the center, drop that pair of tongs, and drive that down on top. So I'm going to dry run that several times so I have that well in my mind before I actually bring these up to heat. I may shop around for different tongs here real quick. And getting it centered is going to matter, but if it's off center when I weld it, it's just going to be off center forever. And it's not a big deal. I've got some old ones that are really off center. So I'll do that a few more times. You don't need to watch me rehearse. I'm also going to make sure the fire is clean and there's no clinkers. Feels like there's a little one back in there. So I'm going to get that out of there. Get the fire good and hot and bring these up to heat very slowly. There are a couple of things to think about while we do this weld. One is that these are two dissimilar materials. One is probably 5160, so a fairly medium carbon steel, and the other one is mild steel, which is a low carbon steel. The higher carbon, the 5160, will come to welding heat at a lower temperature than the mild steel will. So I need to watch that. I need to try and keep the mild steel in a slightly hotter area of the fire as they come up to heat. Or perhaps a little bit deeper and bring the tool steel part higher up in the fire so that it doesn't heat quite as much. But one way or the other, I need to try and get them to welding heat simultaneously, even though the welding heat isn't exactly the same temperature. There's a crossover, so there's a point at which they will both weld. But if I can keep from burning that 5160, I'll be happier. The other thing is, typically flux flows into a joint very nicely on scarf type welds, but because there's no seam assembled in here, I'm just going to flux the surfaces and kind of hope for the best. And after the initial weld, I'll reflux, and that should get down into the seam nicely and help clean it and get all the junk out. Hey, if I let these two pieces touch in the fire, they want to stick to each other, so we're getting really close here. Of course, that one's starting to sink down in the fire where it's going to be hard to grab. You don't want to bring one out of the fire until you got a good grip on both of them. Got a few sparks there. I think we might have done it. That's actually my third pass. But because I had everything heavy enough and thick enough, I didn't lose too much size getting there. So now I'm going to flux that seam. I'm going to put this back in the fire and see if I can get the whole thing hot again. Feeling pretty good about this. It's really crooked and really wonky, but I think we're going to be able to save that. And the next thing I'm going to do is I'm going to give it just a little squish under the hydraulic press to really seat that solidly. I took a little time and cleaned the fire out, got another clinker out of there. There were 3 heats to actually get the weld to stick, and then I've done 3 heats since then to kind of refine the weld. So there was enough stuff in there from flux and a little bit of burnt project. But it is stuck, and we're going to bring it up to welding heat at least one more time, and now I'm going to make it fit the hardy hole. This thing's really kind of wonky and it doesn't quite fit the hardy hole. But now we can drive it down in there. And because that hardy shank is a little bit big, we're actually refining the weld at the same time. This is the part that makes me nervous, trying to get everything back in line. I think we are in pretty good shape there. I don't see any sign that that weld wants to fail. We're still crooked, so I'm going to try and straighten some of that out. And I'm going to go 90-degree turns in the hardy hole to make sure it seats properly every time. So I'm going to use a flatter to try and make this as smooth as I can. And pretty straight across the top. I no longer want that upset, but it's pretty much gone from the welding process. I'm going to go all 4 quadrants. Just to make sure it sits flat no matter how I bring it in here. So that's just the base for our tool, or the basis for our tool. I've actually kind of abused that weld a little bit, and it's still stuck, so I'm pretty happy. I don't see any signs of it opening. Next thing we need to do is create our depression in here, and I need to make a master for that first. I had to take a little run to the post office, and while I did that, this air cooled mostly. It's still too hot to hold without a glove on. And then I ground it and I cleaned it up a little bit, and I get a better look at the forge weld. And I'm quite happy with that forge weld. I wasn't sure there for a while when I missed it the first 2 times, but sometimes persistence pays off. So the next thing we need to do is heat it up again and sink the impression of the handle in there, and that's the handle flat. We bend the handle to shape after we've swedged the kind of domed shape to it, or the oval. And for that, I've made a master the way I want it. This was a rod, I think is S7 tool steel. I forged it roughly to shape. Well, it was still at heat. I just let it air cool, and it came out real hard. So I'm sure it's an air hardening steel, and pretty sure S7. That's S7 and H13 are the only air hardening steels I ever buy. And I don't buy much H13. It's really expensive. But that's a good steel for doing this because it will hold up to hammering on the hot material. So I'm going to give this a little bit of a temper because I think it may be harder than I want, and I don't want to crack it. So I'm going to give this a good tempering before we get to work. Then we're going to heat this up, and we're going to sink that in there just with a hammer. And if I can manage to hold the bar and the flatter, if I did get a hammer, we'll finish it off with a flatter on top so it ends up good and smooth. I'm going to center this as well as you can. The first few hits are the ones that are going to define where this goes. That's going to be some tough stuff. But we're starting to get a little bit of an impression. It pays to line this up every single blow. I think I'm going to want to get that just almost to welding heat. That just does not want to move. That's good because it's going to be a good tough swedge when I'm done. Now if I were making this with a arc welded handle or arc welded stem, I would have done this impression first, either under the hydraulic press or the power hammer. But since I don't have a big hardy stem for the power hole for the power hammer, I can't get this in there. This is where I wish I had a striker, because I'm going to try and get all this balanced on here and swing a 6-pound sledge all by myself. which clearly isn't going to be the best idea in the world. So that's not really going to work. I do not routinely swing a 6-pound hammer, nor will I do this for very long today. Let's try thinking upside down and backwards just real briefly here. Pardon my armpit. I think that's working pretty good. One of the reasons I wanted to try that under the power hammer is I noticed this has been getting kind of sway backed. That also upset our hardy shank a little bit, which isn't all a bad thing. This thing has ended up longer than I intended, which may be a problem in the long run. That's about done. If I need to, I'll trim the ends. I'll do one more heat and make sure I turn it around the other way to guarantee it fits the anvil just right. Luckily there's one longer end and one shorter end, so I know I want to turn the longer end this way this time. So, there is our finished swage. That may need a little sanding and polishing in there, but I'll see after it cools. So that's my project for the afternoon. I started that about 1:30, and it's when I made the decision, this is what we're going to do for the video today, and decided I was going to go ahead and make that and do it as hard the possible way as I could, and probably was the hardest way I could have, but I'm also going to be way more proud of that tool than I would have if I had just sunk it in a flat piece of tool steel and then arc welded a piece of square tubing to the bottom side. It would work just as well in the long run. It would have gotten me back to work several hours faster, but I've never tried this, and I got to do it, and we managed to pull it off. We had a little bit of difficulty, but we overcame that, and shows you what can be done. I don't recommend this as a beginner project, and maybe not even an intermediate forge weld. It's the first time I've ever tried a weld of that nature. But like I say, I started that at 1:30. It's about 5 o'clock now. So that's about 3.5 hours to make that tool, not including final finishing and grinding, whatever it needs, and hardening and tempering if I choose to do that. Right now it's air cooling or normalizing, which will de-stress it quite a bit, and it'll probably take an hour, hour and a half for that to cool off enough to touch it. I may go ahead and decide then to heat it up and anneal it, which will soften it even further and de-stress it as much as possible. And if I do that, then I will harden and temper it. If I just normalize it, I might use it the way it is, and I'm going to sleep on that and try and decide. But 3.5 hours from concept to scrounging around my materials piles, trying to figure out what I was going to use, cutting materials, even moving the camera around and setting up the shots. And you didn't see all of the steps involved. I did skip some just to save some time, because this isn't really a how-to video. It's not a step-by-step procedure. So I did a few things off camera to clean up some crooked edges and things like that. But like I say, all totaled, that's 3.5 hours to make that. That's not bad for a custom-made, one-of-a-kind tool that if you did it right, you're going to have the rest of your life. So I think it was worth doing the forge weld. I think I'm going to be glad I did. I'm going to show that off to some people, and probably tomorrow we will get to work on making 1 or 2 of these handles, and I'll show you how to do it without that swage and how I do it with the swage, just so you can see. But these are fairly simple handles. They don't take that long at all. These are about 10 or 15 minutes each. So we can do a couple of these in a video tomorrow, and we can take a closer look at the finished swage once it cools off enough to actually handle it. Now, I started that with a piece of leaf spring, and the leaf spring was only so long, and it was that long because it had fractured. It had a break on both ends. Now, I cut it back about 1/2 inch to start with, and then cut my piece out of it. But if you're using salvage materials, they have been stressed. This spring was stressed to the point that it broke at some point. Is the piece that I cut out of there going to break next? I don't know. I'm taking a chance that it's going to be good steel, and it held up through forge welding and forging, so I think it's going to be just fine. But it's something to consider when using salvage materials, especially salvage materials that already show signs of stress. The other thing about this leaf spring is it's got this oval hole in the middle of it. Now, I don't know how often I need an oval hole that big, but sometimes you need bolster plates to drive a punch through and support your material while you're punching. So I'm going to cut that off, and I'm going to save that hole just so I've got a nice little oval bolster plate already made and already hardened and tempered. All I'll do is cut it off on the saw, grind the edges clean, and it's done. So keep your eyes out for found materials that may already have a tool built into them that you might need. But that's it for today's video. I hope you enjoyed it. I hope you learned something right along with me, even if I wasn't really trying to teach today. Hope you can get out to your shop and make something, even if it's not quite that complicated. Give the video a thumbs up, hit that subscribe button, share it with your friends. Leave a comment if you got any questions. I'll try to get back to you. In the meantime, stay safe, wear your safety glasses, and we will see you tomorrow.